Okay, gang, chapter 4 review number 45. They're asking for concavity and inflection. So concavity and inflection are a second derivative characteristics. So I have to find the second derivative. Okay, so I have to figure out where the critical points are on the second derivative. Let me just turn this light on. There we go. Okay. Okay, so I have to figure out where negative cosine of x is equal to 0. If you divide off the negative, you get that. Okay, cosine is equal to 0. And by the way, it's on 0 to 2 pi, so just on one revolution. So cosine is equal to 0 on one revolution at pi over 2 and 3 pi over 2 according to the unit circle. Okay, the unit circle. So x is pi over 2 and 3 pi over 2. You guys should have learned the unit circle in pre-calc. I can try to dig up that video if somebody needs it. Okay, all right, so now we're going to look at the behavior of the second derivative. Now, unlike some of the other second derivatives we've looked at, we're capped, right? We're capped. There shouldn't be arrows on the end of this because we're capped. We're just analyzing between 0 and 2 pi. Okay, so I put down my critical numbers, my critical points. So I'm going to look at, I'm going to do test values now. Now it's really up to you what you're comfortable with. You can certainly have a calculator with you, but you might want to just grab some that you might know what they are. Like pi over 4, you should know that from pre-calc. In between pi over 2 and 3 pi over 2, you could use, for instance, pi is a good choice. Here you could use like 7 pi over 4. Again, hopefully if anybody's a STEM major, your trig is really savvy. Okay, so pi over 4, I'm going to plug that into the second derivative. Now be careful because we've got this default negative, so everything's going to be like opposite of what it would usually be. So like for instance, if I do cosine of pi over 4, that's going to end up being radical 2 over 2, but it's negative cosine of pi over 4, so it's negative radical 2 over 2, so that then this is going to end up being negative. We know, if you sort of get confused, pi over 4, we know that the cosine is positive, the plane cosine is positive from 0 to pi over 2. Right, the cosine is positive on the left, positive on the right, negative on the left. So you could also just, you don't even have to plug it in, you just sort of know from the quadrants. That would be concave down. Remember, make sure you make second derivative conclusions. Second derivative is looking at concavity or twisting. So this would be bending down if it's less than 0. All right, now again, we're going to put in pi, but I'll change the sign in a moment. Cosine of pi, you're on the unit circle. On the unit circle, the cosine of pi outputs a -1, but again, you're doing negative cosine pi, so you're negativing the negative, which makes it a +1. So that makes this positive. That's concave up. And then we're doing cosine of 7 pi over 4. Now you should know from just the quadrant you're in quadrant 4, cosine's positive in quadrant 4. So we just know by default that's positive. I'll give you the output value. But then again, it's negative. We're going to negative these values because of this guy again. So then this is negative concave down. All right, so let's just write down the concavity since we've gotten it. So it's concave up. The function itself is concave up from pi over 2 to 3 pi over 2, and the function is concave down from negative, let me write this correctly, no negative anything. I was going to say negative infinity, but right, we're capped here, so we're not, we have to say 0 to pi over 2 and 3 pi over 2 to where we're capped, which is 2 pi. Okay, so that's the concavity that I'm grabbing off of my data that I found. All right, so now let's look for inflection points. So remember, an inflection point is when you change concavity around a critical point. So as long as you change concavity around a critical point, that's what you're going to get. So right here we can see it's an inflection point because we changed concavity. I'm just wondering if I can squeeze this here. If I can't, I'll just grab another sheet of paper. So we have an inflection point of pi over 2. I'll go back and get the y value in a moment. And we also have an inflection point here at 3 pi over 2 because we're changing concavity again. So these would be points that you would put on the graph. So that would be from graphing the original function. I'm just wondering if I can squeeze this in here. So now you have to plug these values into the original function. So like I would do f of pi over 2, which would be, I plug it in here, so I would get pi over 2 plus cosine of pi over 2. Now cosine of pi over 2, as you know from the unit circle, is going to be 0. So that's just going to be pi over 2. So the input is pi over 2 and the output then is a pi over 2. Now that pi looks weird to me. Okay, good. All right, now I'll do it with the other one, the 3 pi over 2. I'll put it in here. So f of 3 pi over 2 is 3 pi over 2 plus cosine of 3 pi over 2. Cosine of 3 pi over 2 from the unit circle. Again, if you guys don't remember this, I can give it to you. Just shoot me an email. Cosine of 3 pi over 2 is 0. So 3 pi over 2 plus 0 is 3 pi over 2. So this is 3 pi over 2, 3 pi over 2. And that would be the inflection points. All right, gang, that's what they asked for. So I hope that all made sense. I know sometimes the trigonometry can be a little bit more difficult, but I hope I explained that so you're all good now. All right, keep having fun with the math. I'll catch you.